Good morning, ladies. Let's recap quickly. Last time we looked at the general gas equation, and I said to you this is a combination of the three gas laws that we have already looked at. So just to remind you, this is what the formula looks like. So over here, you can see the P1V1, P2V2, that was Boyle's law. You can see the P1 divided by T1 and the P2 divided by T2. That was Gay-Lussac's law. You can see the V1 divided by T1, V2 divided by T2, and that was Charles's law. So this is what we'll use if we work with a changing pressure, volume, and temperature simultaneously. So just a reminder there, the two pressures must have the same unit, the two volumes the same, and the two temperatures, of course, must be in Kelvin. Right. The next one, and this is the last one for this section, is called the ideal gas equation. And that is what it looks like. So PV is equal to nRT. So for the first time, we are actually also going to look at the number of moles of the gas present during the calculation. So if we take a look at this, P, as you know, is going to be pressure. The other very important thing about the ideal gas equation is that for the first time, the other quantities like pressure and volume have got specific units in which they must be measured. So if I'm using the ideal gas equation, pressure must be in pascals. V, of course, is volume, and that must be in meters cubed. N is the number of moles. T is temperature, and it must still be in Kelvin. And then this is the first equation that also has a constant, and R over there is the universal gas constant, and it is equal to 8,31. So it will always be that, and that number will appear on your data sheet as well. Let's take a look at an example, and this example is from your textbook, so you'll find it on page 149. Calculate the temperature of 20 moles of oxygen which are in a container of 500 decimeters cubed at a pressure of 96 kilopascals. So T is what I want to work out. 20 moles I've got in. V, the volume, is given as 500 decimeters cubed. But since I know I'm going to use the ideal gas equation, I know that the volume must be in meters cubed. I've done this before, but just another reminder. The factor between each one of the units is 1,000. So if I want to take the decimeters cubed and convert it to meters cubed, I must divide by 1,000, which is the same as saying times 10 to the power of negative 3. So I've taken the 500, divide by 1,000, and that gave me 0,5 meters cubed. Or if you want to, you can just write it as 500 times 10 to the power of negative 3. So that is, of course, exactly the same number. This is just written in scientific notation. The pressure is given as 96 kilopascals. And for the ideal gas equation, pressure must be in pascals. So a kilopascal is equal to 1,000 pascals. So if I convert kilopascals to pascals, it's times 1,000, which is the same as saying times 10 to the power of 3. So my 96 kilopascals will be 96,000 pascals. So there is the formula. PV is equal to nRT. I've substituted all the values. I want to work out the temperature, and of course R is always 8,31. I've done the calculation, and the answer is 288,81. And of course the temperature is going to be in Kelvin. And because they just say calculate the temperature, we've got a temperature answer in Kelvin. So this is where you stop. If the question was calculate the temperature in degrees Celsius, you would have done all of this, and then the extra step would just be to convert the Kelvin to degrees Celsius. Okay, here's another example. This isn't from the textbook, so let's just take a look at this. A certain amount of oxygen gas is collected in a 250 cubic centimeters flask. The pressure of the gas at 25 degrees Celsius is 120 kilopascals. Calculate the mass of oxygen gas in the flask. Now, I don't have a formula where I can calculate mass. I've only got my ideal gas equation where I can calculate moles. But if I've got moles, I can also work out mass, because I do have an extra formula where mass and moles are related. So let's take a look. So I've got volume, 250 centimeters cubed. I'm going to use the ideal gas equation so that I can work out the moles first and then work out the mass. So I have to convert my centimeters cubed to meters cubed. So I'm going to divide by 1,000,000, because centimeters to decimeters and then decimeters to meters, which is exactly the same as saying times 10 to the power of negative 6. So I've taken the 250, I've divided by 1,000,000, and I got 0.00025 meters cubed, or I can just say 250 times 10 to the power of negative 6 if I want to use scientific notation. The temperature is given as 25 degrees Celsius. I've added the 273 to work out the Kelvin temperature. The pressure is given as 120 kilopascals. I've multiplied by 1,000 so that I can convert to pascals. And I've written down my formula. Now, in my first worked example, I substituted my values immediately. In this worked example, I have manipulated my formula, and I got N alone on one side and then substituted the values just to show you that you can follow either one of the two methods. So N is going to be PV divided by RT. R is my gas constant, universal gas constant, 8,31. I've done the maths and I've got so many moles. But the question was, what is the mass? And I'm sure you remember this formula. Number of moles is equal to mass divided by molar mass. So the mass is going to be number of moles times molar mass. The number of moles are worked out over there using my ideal gas equation. And then the molar mass for oxygen gas, that's where I need my periodic table so that I can look up the mass. And oxygen has a mass of 16, but it's oxygen gas that we are talking about, which is diatomic, so it's actually O2. So it's 16 plus 16, which gives me a molar mass of 32 grams per mole, which I have substituted over there, and I get the answer 0.38, and mass, of course, is going to be in grams. So 0.38 grams is my final answer over there. And then just one more worked example that I want to show you. At what pressure will 16 grams oxygen gas occupy a volume of 10 decimeters cubed at 77 degrees Celsius? So what I want to work out, pressure, I've got the mass as 16 grams, volume is 10 decimeters cubed, I have divided by 1,000 and I've converted to meters cubed. Temperature 77 degrees Celsius. I've added 273, so I've got the Kelvin temperature. I've written down PV is equal to nRT. Pressure is what I want to work out, so it's going to be N times R times T divided by V. I don't have the number of moles, I've only got the mass, but I can use my formula to work out the moles, because moles equal to mass divided by molar mass. The mass is given as 16 grams over there. The molar mass from my periodic table, 16 plus 16, exactly like we did over there. and I get 0.5 moles. So I've got that. R is the universal gas constant, always 8.31. Kelvin temperature, volume, and there's my answer. And because it's the ideal gas equation, I know when I calculate pressure, it is going to be in pascals. So over there, 145,425 pascals, my final answer. And then, of course, a couple of questions for you to go work out so that you can also practice to use the ideal gas equation. Thank you, guys.